So this is an ion trap experiment we're running in this lab, for the teaching lab. And it's the Protocase box, which sort of contains all the electronics. And on top of here is a box. And inside, there is about a centimeter and a half ring, a copper ring. And what we're doing is we're applying a voltage, high voltage, 60 hertz to that ring. And what that does, and then we put these particles, these are Lycopodium club moss spores, these little like 25 micron spheres. We charge those up and put them in there, and they're trapped by the electric fields. And that's what's over on the screen here. These guys in the middle, this is the ring, again about a centimeter and a half in diameter, copper ring, and I can turn it a little, and so that's me turning the ring. And they're about 25 microns in diameter, maybe half the diameter of a human hair, each particle. They look like streaks or little hairs in here, but they're not. They're round. And the reason they look like that is this is 60 hertz high voltage, and the 60 hertz is making them go back and forth really fast. And that motion, that back and forth motion, is what actually traps them. And so they're going back and forth so fast the camera doesn't pick that up. So they look like streaks of light. It's all illuminated by a laser. And so we can change the electric fields and move these around, and we can make the trap tighter or looser. And of course, there's a lot of math behind all this. It's not trivial how you trap particles with electric fields. It won a Nobel Prize. So things that win Nobel Prizes are usually not very obvious, and this one isn't either. And one can twirl the ring around a little and see how they move. And so what we do with this is we study how these traps work, and it's just an example of electromagnetism in action. And so it's a dynamical system, and we write down the math and solve it and look at the trapping forces. Another fun thing is we can trap a single particle, not a bunch of them like this, but a single one. We can image it and measure the mass of the particle and the charge on it and directly. And we can measure very tiny forces this way, and so that allows us to really just see how you do stuff like that. And it's all about learning how to use the oscilloscope and collect data and measure things and assign errors and certainties to the measurements. So that's what we're doing, is we're using this as kind of a teaching tool. The center of it all is our Protocase box, which holds everything, and it was just designed with all this in mind, and it works great. We've been using it for years, and very rugged, and we love it.